Good. All right, so this is the graph you got. Sometimes the lines may have a different color, but that's just Desmos, I guess. So, but 3, 1 is the point of intersection here. Here's actually another example. If you were to graph these two, that is, if you graph this system, these two lines are parallel. You can see that they never intersect. I mean, with me, at least, if I put this on the final, you might be allowed to check using Desmos, but I really would want you to see your work. So you'll definitely have to do substitution or the next method I'll show you, which is elimination. But you can still graph as a way to check your answer. So, but graphing is still a way to solve these. But here you can see that this system is inconsistent. There's no solutions. So, all right. Okay, this one I was going to have everyone try. Last class, they did not want to graph it. And see, we got a little behind. Let me just do this with everyone. Let me just show you the answer. If you were to graph this system, okay? Actually, let me graph it with you guys. Let me graph it with everyone, excuse me. Just to illustrate. Okay. So we have negative x plus y equals 2. And then the other one is 4x plus y equals 2, as you can see. Yeah, and you can also press the home screen. That'll bring it back to the origin. But you can see that there's only one point of intersection, the point 0, 2. Okay. One point of intersection, which is nice. Okay, cool. Okay, good. All right, so here's another example we can solve by substitution. So now again, from the first equation, notice this is a little bit different. And why is that? Well, because I'm not getting y in terms of x. Mostly because the coefficient of y is 3, but the coefficient of x is 1. Okay, the coefficient of x is 1. Okay, so I'm going to get x in terms of y. I mean, you could get y in terms of x if you want to. It's just that the work, I think, is going to be a little bit harder, mostly because you'll be working with fractions. Not that that's bad, but if you get x in terms of y, it's a little bit easier. So from the first equation, we can add 3y to both sides. We get x all alone on the left, and on the right side of the equal sign, we get negative 1 plus 3y. Now, what do we do next? We're going to substitute this into the second equation. Okay? Into the second equation. Right? Remember, we have the second equation. We want to use it, right? So we have 2x minus 3 times y. But we know what x is in terms of y, so we have 2 times negative 1 plus 3y minus 3y. That's equal to, right? So now what is this equal to? Well, if you distribute the 2, you get negative 2 plus 6y minus 3y, which is negative 2 plus 3y. And now the second equation was equal to 7, so we have negative 2 plus 3y equal to 7. Good. But now notice we have one equation in only one variable, one unknown that is, and we can solve for that. We can solve for that variable, right? Just like we've done earlier in the course, earlier in the semester, right? You add 2 to both sides. You get 3y equals 9. Okay. You divide both sides by 3, as you can see, and you get y equals 3. So we get x equal, okay, so we get y equals 3. But that's really that's in a sense the hard part, because we know what x is in terms of y. X is -1 plus 3 times y. Right? So x is actually -1 plus 3 times 3, which is -1 plus 9, which is 8. So the solution, the only solution, is this ordered pair. So this system is consistent, and the equations are independent. Or linearly independent, same thing. All right. Any questions on that? Okay. And if you graph it as a check, this is the graph, you would get something like this. I mean, I don't know if the lines would be red and blue, but these would be the lines you get. 8, 3. Okay. So we were right. Okay. Now here's the other method for solving a system like this, called the elimination method. In this system, what we want to do is this. The whole idea here is you want to somehow combine the equations together to eliminate a variable. So here, for instance, you're going to, as in step 1, adjust the coefficients. In other words, you're going to multiply either one of the equations or even both of them by numbers to get new equations, so that the coefficients of the variable that you're going to eliminate, they're opposite in sign. So in other words, you'll see when we do some examples, but you're going to multiply one or both of the equations so that the coefficient of x, let's say, in both equations, they're opposite in sign. So one of them is 2, the other is -2. Or for y, you could also do the same thing, and you can get the coefficients to be 2 and -2, 4 and -4, opposite in sign. You add them together because that'll kill off a variable. In that equation you get in one variable, you solve it. Okay, you'll get one equation in one variable, you will solve it. And of course, once you get that answer, you plug that number in. Once you solve it, you plug the answer into one of the two original equations, and that'll give you the other variable. Then you're going to write the solution as an ordered pair, and it's good to check your results. That's the elimination method. And again, we'll go through some examples to illustrate it. Okay, so for example, let's solve this system using elimination. Okay, right away. Okay, so looking at these, here we have 2x and 3x. If we add those, they're not going to cancel. Here we have 3y and -4y. Adding those won't cancel y. And of course, we have the constants. What we could do is multiply the first equation by 4, the second equation by 3. Okay, by doing so, the 3y will become 12y, -4y becomes -12y. And then you can add and kill off the y. So let's do that. And there's more than one way to eliminate a variable, as you'll see. So for instance, here you can multiply both equations by 4, and you'll get 4 times 2x plus 3y equals 4 times 21, which is 8x plus 12y. That equals 84. The second equation will become multiplied by 3. You get 3 times 3x minus 4y. That's 3 times 23. And of course, that's going to be 9x minus 12y, which is 69. So now the two equations become this. And I should say this now before I forget. These two systems have the same solution set. When you take an equation and do stuff like this, you multiply both sides of the equal sign by a non-zero number. or you add one equation to another, you're not changing the solution set. I mean, if you multiply both sides by 0, then you would. We don't want to do that. So, okay. But now here we can add the two, and the y's go bye-bye, right? When we add them, we get 8x plus 9x is 17x. The 12y's go away. 84 plus 69, that's going to be 153. So now the equation we have to deal with, right? One of the variables is gone. We have 17x equals 153. So 17x is 153, right? But again, we want x, so what do? Divide by 17. We get x is 153 over 17, which is 9. Now we know what x is. What do? We take that x and put it in to one of these two equations, the originals. I chose the first one, but you could have done the second. So we have 2x plus 3y is 21, right? That's the first equation. X is 9, plug it in. 2 times 9 plus 3y is 21, right? So we have 18 plus 3y is 21. Okay? And what do we get from here? We subtract 18 from both sides. We get 3y then is 3. Almost said negative 3. But we don't want 3y, we want y. So we divide both sides by 3, we get y equals 1. So we have x is 9, y is 1. The only solution then is 9, 1, this ordered pair. So that's what we get. All right, cool. Any questions on that?